Live streaming is on.
Session notes, right, for documentation. So we're doing documentations here. We went over our values. We went over our priorities list. We went over our list of all the levels of security for all the documentations, and we went over an example of the main doc, of the different types of main communication documentation locations, right? And then I wanted to go over the example of the session notes. So session notes is created, as a, level 0, level 1 open document for the session, unless obviously there's any problems that happen. And then basically immediately after the session, the document can be made level. It would be view only. 5. Level 5. Actually, probably level 4. Yeah, level 4. Comment only, right? So that people can still make comments about the session, but they still have access to view the notes. Okay. So that I think is obvious. And then from there, the other example would be the
some documents that are verified. Like once we verified, like for example, the payrolls, we do the team verification, the proposal verification. That tab should be
time for breath.
Should become restricted once it's verified.
Sure. Yeah.
Inhale. Exhale. Inhale together. Exhale, relax. So that we know for sure that we know for sure. Cannot know for sure, but we are confident that next time we use that information to keep for the work to move forward. We know that it has not been manipulated.
Yeah. But in terms of finishing with the session notes, the other type of notes is we have the umbrella notes, right? Which we still don't use, which is annoying because I brought it up like 100 times. But either way, the umbrella notes, for example, you would typically have an umbrella notes for, the half year. And so during that half year, the umbrella notes would be open. But then once the half year is over, the umbrella notes themselves get archived and made comment only, right? Okay.
Yeah.
It's also interesting to note that a lot of these documents and all of the pads, the way that you would back up some of the pads is you create HTML versions, right? I'm pretty sure a lot of these can be downloaded as an HTML version, but I don't know, version history make available online. So add shortcut to drive, rename, download. So if I go to download, I can download as a web page of HTML. So once you actually are verified and create a document that's basically doesn't need to be changed anymore, you can actually download it as an HTML, upload it into the server, and then it's literally available forever as a web page. It's fascinating, right? And that's how we do a lot of our pads. A lot of our pads are like available online as web pages that cannot be manipulated, That's also how the file system works that I was telling you about, like the file system for that, the cryptographic file system. It's all basically based on web page file documents that once the document is uploaded, it's unchangeable. It's irreversible. It's like a blockchain. It's like you can't reverse the transactions. Once you upload the document, that document can never be
time
changed.
to pause.
Document.
Yeah. So
uploaded where the document?
Into the online document, like it's like the distributed document system, right? It's a distributed document filing system. I told you all about it, didn't I?
No, Not all about it, but you.
Well, I'll give you.
You started it.
This is another very important
Introduce your argument.
documentation. So another thing for our documentations priority list is our decentralized documentations model setup, right? So let's go into that for a second, because this is where everything ends up. So in the end, everything ends up in our decentralized cryptographic database of documents, okay? This is the only thing at this point, based on the technology that we have available, which will actually live and exist in 1,000 years from now, right? There's only two options for things to exist 1,000 years from now. One would be like a time capsule. But the problem with a time capsule and basically creating a single version of something is that it's not accessible to anyone. No one has accessibility to it. And if it gets damaged or broken, it's gone, right? Whereas a decentralized documentation model, everybody has access to it across the entire world forever. And it just never goes away. So it's a much better option for what we want, right? So
unless the world goes away.
Well, but then it doesn't matter anymore, right?
Doesn't matter anymore. Yeah.
But
what happens if, for example, the world goes back to the Stone Age and then it goes back to a technological advance? They would still be able to.
The way I define our systems, right, is that there's two components, right? The first is a society, right? So we have a globalized society that exists currently, right? And the goal is for our society to continue, right? And improve, right? But the problem is that if our society dies, humanity and actual human existence does not have to die, but our society could die. And our society basically people believe in the past that there's been societies that have lived in the past that did die, and they were not able to pass on their knowledge to us. Then we lost knowledge from 10,000, 20,000, 30,000, even 50,000 years ago that we currently do not know and do not have because of the gap that basically it was lost, right? So
yeah, for sure.
So a society dying means that all of the data and knowledge is not passed on to future generations. So obviously that's what we're trying to avoid. The second thing.
Time to take a break.
Let's skip this break again, because I have about 5 or 10 more minutes. I gotta go.
Okay.
So anyways, the second thing is that what our goal is in terms of creating institutional infrastructure for new economic infrastructures, new decision-making infrastructures, and new educational infrastructures is building the vortex into a brand new civilization that is a type 1 civilization, right? So you have basically continuity of society, and society will continue even within a civilization, right? So within a type 1 civilization, which is our goal, you can still have multiple smaller societies that could evolve and grow out and branch out and everything, right? But the civilization itself would basically take over the primary role of
the society, the global society
of this history. Yeah. But right now, obviously, we're not even a civilization; we are a society, based on the definition that we're using, because we're using basically the definition that a type 1 civilization is the first actual civilization that has the ability to basically outlive the planet itself, right? Which could be billions of years.
Yeah, outlive the planet, and I mean, how they define the type civilization is type 1 civilization is the civilization that has the technology to basically harness energy from the sun. Directly from the sun, but I don't know if that's what you mean.
No, I think that's a type 2 So a type 2 civilization is able to harness the maximum amount of energy from the sun. A type 1 civilization maximizes their ability to thrive on a planetary level. So basically, we want to maximize the amount of energy that we can get from our planet, which includes maximizing all the energy that comes to our planet from the sun, which is literally 1% of the energy from the sun. A type 2 civilization is maximizing all of the energy from the sun. right? And that's part of why. I mean, there's two types of civilizations in the galaxy. One is that any smart civilization would never go for a class, 3-star like ours. Like you would always go for brown dwarfs and smaller stars because our star lasts like what, 5 billion years, right? 10 billion years, maybe 20 billion years at most.
Yeah.
Where you have these other smaller stars, what can burn for like hundreds of billions of years. Tens of billions, hundreds of billions of years. So if you have very limited resources to travel throughout the galaxy, you would almost always travel to a dwarf class star that would be have all of your energy needs available for 10 to 100 times longer than the kind of star that we have. Right. Then the other thing is that when you have a type 2 civilization, they basically would be dimming their star, and their star would be very difficult to see from anywhere else in the galaxy because, first of all, it's probably a brown dwarf star, so it's already hard to see. And then second of all, they basically build an infrastructure around the entirety of the solar system to capture all of the energy from the star. So basically, a type 2 civilization might most likely has a dark star, which is very difficult to detect.
The so-called Dyson sphere, that kind of
Exactly.
technology. Yeah.
Yes.
Yeah.
Right.
They were
Anyways,
discussing.
Yeah. So, anyways, our goal is a type 1 civilization, right? And our goal is a continuation of society. So, in relationship to continuation of society, our options for the decentralized cryptographic databases are as follows. So, it's a very simple model. Basically, it's kind of like nodes. Like, how we want to copy all of our documentations and have it stored in multiple nodes across the world. A decentralized model of file systems is all based on nodes. So you have a decentralized file system of nodes, right? So these nodes copy all of the files across the world into like, all these nodes. Let's say there's 1,000 nodes, right? And for a really important document that the humanity and our society feels is very important, it might have 1,000 plus copies, possibly even millions of copies, right? That makes sense?
Yeah.
So now let's think about what it means to have a file on Wikipedia. Okay, so Wikipedia is what's called a location-based system. And so it's based on a URL. The URL of that data is a specific location on the web. And so in that context, you have the Wikipedia file is located physically in one single location on the planet. They can do there is such a thing called a mirror site, which can mirror a website through a duplicate process of servers, but the location is the
It's
same.
5 o'clock.
It's just a mirrored site. So does that make sense that it's a centralized system?
Yeah, totally centralized. Yeah, one single location.
One single location, one single address. If that particular address and location goes down, the data is no longer available and you can't access that Wikipedia page. Does that make sense?
Okay.
Whereas in a decentralized system, if the document you're trying to find is no longer available, someone deleted it or that server went down, you still have 999 other locations you can go get it. Does that make sense?
Yeah.
Okay, so the way that this model works for the decentralized file system, which is where we want to put all of our documents, is called the basically it's a cryptographic key.
Cryptographic, how do you call it? Database.
And in this case, it's a public key. So you use a cryptographic public key. So this public key, which obviously we know is kind of like Bitcoin or all these other things where basically you have all these letters and numbers and stuff, right? And it goes on for a really long. Does that make sense? Are you following me?
Yeah, I am.
Okay, so you have these super long letters and number things that are the key, to that information. So the way you store information in a decentralized file system is with a key. So as long as you have that key, you can access that information anywhere in the entire world.
Okay, cool.
So the information, instead of being based on a
Yeah, but the
location,
information is stored in various locations, but you need the key to access the information. But the information
yes, because there's
centralized.
so many versions all across the world, basically all of the data is just mixed up. So the only way to actually access the data is with the key.
Correct. Yeah,
And you
got
can
it.
even store
get it.
partial. You can even store partial files. You know, if you have 100, if you have like, let's say, you know, a gigabyte of information within a key, that gigabyte can be decentrally stored all across the world, and with that key, you can put it back together. Right.
Cool.
So the key is not the key is the access to the information, because it pulls everything associated with that key, every single bit associated with that key, and it can the key puts it back together so that you have access to it on your computer.
This is really cool. I mean, it's like kind of super security because.
Well, actually, it has nothing to do with security. I'll talk about the security next. So,
but I mean, yeah, okay. I'll keep going.
Yeah, so let's just use an example of a Wikipedia page, right? So Wikipedia, and I can get examples for the other one as well. But let's just go to English. All right. So here's a Wikipedia article on John C. Young, random pastor, okay? So this is the actual link to the location on the planet where that article is, okay? So in order to access the secured part of that, you have to have the login to the server to access the files. Does that make sense? And typically with Wikipedia, you can have a login to be able to edit or at least make comments on the file and everything. But either way, there's a login to have access. Does that make sense?
Yeah.
With the cryptographic model, you have a cryptographic private key. And the difference between the private key and the public key is that the public key represents a single data file in snapshot. So this is what we call the snapshot. So the snapshot is unchangeable forever. It's like making a transaction in the crypto, like a crypto transaction. Once that transaction has been completed, it can never go back, and that transaction represents that snapshot in the past of when that transaction happened, and then it's no longer, you know, current, because now the Bitcoin or the crypto token is in a new location. Does that make sense?
Yeah, of course.
Right. So that represents the public key. The private key is what we call the data pointer. Right. So the private key basically, in this obviously you have only the person who owns and controls the private key, which again is very similar to the public key, except, you know, different, right? It'll just be different but similar, right?
Okay.
So this private key, actually the private keys are typically a lot longer, though. So let's make it longer, okay? So the private key will, what it does is that when you create a file model based on a private key, then the private key points to the public key that is current. So what that means is you can have 100 different edits to a file, but the private key points the public to only the current version. But all past the other 99 versions would also be publicly accessible, but nobody would know which one is the current version. Only the person who controls the private key can point someone to the current version. So in our case, for example, if we had a document that we were never going to edit ever again, you would never need a private key. You just upload it publicly and then it's done forever. But if you have a document that is actively being edited and changed, you would have a private key so that you can access the editing and the changing of that document so that people are pointed to the most current version. And then the moment that no longer need to edit it, or if we disappeared as an organization, right,
Yeah.
there'd be no more edits. And so then the public would just be left with the most current version or whatever was the most current version, and then it would never be changed again.
Okay.
Do you get it? How it
Yeah,
works? Okay, cool.
Yeah, I get it. Yeah.
But once you upload a document onto basically the cryptographic decentralized file systems, it's unchangeable forever. And the only way to change it is with a private key that will point people to just the current version and skip the other 99 versions.
Pretty cool.
Yeah. So that's the only way to do it. But all of the other versions will always be available and accessible online forever.
Yeah.
Or as long as somebody feels that they're important, right? And so this is where it comes in, where like if your documentations are a lot of gigabytes in space, but people don't value them, then they will get deleted off of what the society believes should be kept into the future. So our goal is creating documentation that is very important and people believe is useful and that they want to store on mini servers and save forever. So that's why what we want to do is we want to create a very small list of documents that we are proposing to present to the public for the decentralized system. From there, we can have our own documents on the decentralized
write this down.
node,
Yeah,
but that would only be on our own node. And then as soon as our node goes down, all of those documents would get deleted. Does that make sense? But who cares about that? It's like, we don't really care about that. What we care about is presenting a public perception of all of our documentation that then can be stored forever. Yeah. And so that's all that really matters. Once we get that set up, then we can, have other documentations that we use temporarily, that people may or may not store. But the main thing is having a set of documents that we intend that our society will store forever.
Correct.
Yeah. Okay.
Very cool. Yeah, very cool.
Awesome.
So next steps. I mean, we should start working on our documentation.
Yeah, I have to go. So, I mean, when we get back, we can keep going. The bottom line is, what do you need in order to be able to move forward with the recruitment? And then the other thing that I thought about with the recruitment, is remember when I was like, look, we're doing all this recruitment. Why not ask for advisors and, workers and other people who want to get involved, right? Instead of just for the board.
Yeah, I remember, and I was agreeing with you.
Yeah, and I have one other thought on that, which is that if you're going to all the trouble to post all of this stuff, why not also add contributor and ask for donations as well, and have a donation button, a contribute button, not just on the website, but also on the recruitment portal.
Oh yeah, for sure. We should always have a donation button everywhere.
So I was thinking that we just add donors as well, and we just put one sentence like, "Oh, if you want to donate, we need resources to make this all happen." And you can push our contribution button link, and then you can contribute here. Right?
I can do that.
Yeah, so that's. So I was thinking about adding that.
But
and then I'm ready, of course, to start the recruitment. But the question is, are you ready? Like, what kind of maybe we should go over the backups real quick when I get back, and then we go over the backups. We get backups at least of our most important documents, and then maybe we go over our file systems really quick to know what the most important documents are. List. Okay, and then I think we'll be ready, right? I mean, and you should let me know what you think needs to be done before we can start the outreach.
Yes, thank you, Jay. Perfect. So I'll be waiting for you. I'll be creating. So we're gonna keep going with this session, right?
Yes, but I need about 20 minutes. 15.
Yeah, thank you.
Yeah, bottom of the hour. I shall be available bottom of the hour.
So in the meantime, I'll create the donate.
Great. You can check in with Ate and Moth and them if you want to as well. You could have someone join me while I'm gone. So.
I see. I mean, I'll ask them. Yes.